This, my friends, is a typical motherboard. Now, as we look at a motherboard from other episodes, we know things like, for example, this is where we snap in our RAM, and this is where we snap on our CPU. We also know from other episodes that this is the interface by which everybody talks to everybody else on your computer. Except I'm going to take it even further than that. I'm going to tell you that a motherboard is an assumption. It's an assumption in that it assumes that you're going to be putting USB devices on here. In fact, they even solder USB connectors on there. It assumes that you're going to want to use wireless, so it has wireless ready to go. It assumes that you're going to want to plug in speakers and maybe headphones. It assumes network connections, but it assumes more than that. It assumes there's hard drive connections on here. There are all kinds of little different types of connections for all kinds of little stuff. Although this has an outrageously large number of USB connections, the bottom line is that a motherboard is an assumption that you are going to use certain types of hardware. Now, if you think about this, this is a fairly safe assumption. For example, odds are pretty good you're going to use a keyboard. Odds are pretty good you're going to use a mouse. Odds are pretty good you're going to use some kind of mass storage. Odds are good you're going to be using this stuff. Now, that's great, and the motherboard acts as the interconnectivity for these types of devices, but there are situations where your computer needs to talk to these devices not within Windows, but even before the operating system itself boots up. Now, we know that operating systems, one of the things they provide are device drivers. So if I'm using Linux, I have Linux drivers for the hard drive in here. I have Linux drivers for the USB. However, there's lots of situations where before the system even boots into an operating system that we need to be able to speak to these devices. In fact, in many cases, the operating systems themselves will forgo device drivers and simply use some built-in language that allows them to talk to all this stuff. These are known as our basic input-output services, better known as BIOS. And that's right, folks, built into this motherboard somewhere is programming. Now, we use the term firmware because firmware means that it's burned onto a chip as opposed to software, which means that it's copied onto some kind of magnetic media or electronic media. So on every motherboard in existence, there is no exception to this, there is a little bit of programming built into the motherboard that's designed to let you talk to the assumed hardware of the computer. And it's called BIOS. You want to see it? I'll show you one right here. This motherboard dates from the mid-1990s, and I like it because it's got really big parts. And this entire chip right here is a BIOS chip. BIOS chips grow on BIOS trees. No, they don't. BIOS trees are code, and they have to be written by programmers, and there are companies out there that write BIOSes. They have names like AMI, American Megatrends, Phoenix, and there are organizations out there that sell them to any motherboard manufacturer who's got the cash. So that's where these names come from. So this is a very old BIOS. Let me show you what BIOS looks like on a modern system. So if we take a look at here, we've got these two little teeny tiny chips. And right next to it, I don't think the camera can get this, it says MBIOS and BBIOS. What you're looking at is a feature that's common to many motherboards today where they make two copies of this critical firmware. If by any chance we were to accidentally wipe it out or corrupt it, we've got a backup copy on a completely separate chip. In fact, this motherboard comes from a company called Gigabyte, who is famous for doing exactly that. Now, the problem with BIOS is that there's really no way to show it to you. I can't open a hatch up on a computer and go, here's the actual code itself. Can't do that. But what I can do is talk about BIOS a little bit more to make sure we understand what all it can do. Now, for example, on this BIOS, you have the ability to talk to the mass storage devices of your motherboard. So if you snap in an SSD or if you snap in an old school hard drive, you can talk to that drive without even booting into Windows. This is done more than any other reason to test it. As the computer boots up, we go through a process of checking out the assumed hardware. It's not worth anybody's time for you to try to start Linux if the hard drive isn't talking right. There's no reason to try to boot up a Windows screen if you don't have a monitor that can at least output something. So built into our BIOS is also something known as the Power On Self-Test, or POST. We've got a whole episode on POST coming up. The third thing that's built into that chip is something called the system setup. That same hard drive, it's going to change. It depends what your capacity is of the drive and things like that. So some of that code has to be able to read a little data. And that's what we call the system setup, and also known as the complementary metal oxide semiconductor, or CMOS, and I've got another episode on that as well. So when we talk about BIOS, what we're talking about is a little tiny chip on the motherboard that talks to the assumed hardware of the system. I'm going to save it for a few more episodes to show you some of the other denizens of that little chip.